Welcome to the Greek Corrosion channel. My name is Mariam Ehtishamzadeh. An introduction to this channel is available on video number E28. Chapter 9, Section 3, Risk-Based Inspection. Mechanical integrity focused. Terms and definitions used in API RP 580. The reference: Elements of a risk-based inspection program, API Recommended Practice 580. What is risk? Risk is the product of the probability of an event or failure occurring during a time period of interest, or POF, and the consequences, generally negative, associated with the event or failure, or COF. Risk equals probability times consequence. Acceptable region: as low as reasonably possible, ALARP region. Not tolerable region. In the two-probability approach to risk, the first probability term, P1, describes the probability that the presence of a hazard will result in a hazardous situation. The second probability term, P2, describes the probability that a hazardous situation will result in harm. Risk plot. Risk plot is shown in this figure. Vertical axis, probability or likelihood of failure. Horizontal axis, consequence of failure. And here is the ISO risk line. Industry scope of API RP 580. American Petroleum Institute Recommended Practice API RP 580 outlines the framework for risk-based inspection, or RBI programs. This RP is specifically targeted to the application of RBI in the hydrocarbon and chemical process industries. The principles and concepts herein can be applied in other industries with appropriate documentation. Asset integrity. Asset integrity, also known as asset integrity management, AIM, refers to the practice of ensuring an asset's ability to perform its intended function safely, effectively, and efficiently throughout its entire life cycle. It encompasses all aspects of managing an asset, from design and construction to operation, maintenance, and eventual decommissioning. Mechanical integrity focused. The RBI process is focused on maintaining the mechanical integrity of pressure equipment and minimizing the risk of loss of containment due to deterioration. RBI is not a substitute for a process hazards analysis, PHA, nor is it a substitute for hazard and operability assessment, HAZOP. Typically, PHA risk assessments focus on the process unit design, operating practices, and the adequacy of the practices, given the unit's current or anticipated operating conditions. RBI complements the PHA by focusing on the mechanical integrity-related damage mechanisms and managing risk through inspection and complementary mitigation and/or monitoring programs. There are other relevant relationships between RBI and other equipment reliability or risk assessment programs in the industry. For example, RBI is complementary to reliability-centered maintenance (RCM) programs in that both programs are focused on understanding failure modes, addressing the modes, and therefore improving the reliability of equipment and process facilities. Terms and definitions used in API RP 580. The terms and definitions described in this video are continuation of the video titled Chapter 9, Section 2, or number E40, in which the terms 1 to 20 are defined. Now, 21. Failure mode. The manner of failure. For RBI, the failure of concern is a loss of containment of equipment items. Examples: small hole, cracks, and rupture. 22. Fitness for Service Evaluation, FFS, a methodology whereby damage or flaws, imperfections contained within a component or equipment item are assessed to determine acceptability for continued service. 23. Functional failure. The inability for a component, equipment, or system to perform its intended function. 24. Hazard. A physical condition or a release of an unsafe material due to a component failure and which may result in human injury or death, loss or damage, or environmental degradation. 25. Hazard and Operability Study, HAZOP, a structured brainstorming process of assessing the existence of dangers and/or risks, that is, hazard, in equipment and vulnerability of operation. Note: the process uses a list of guide words to focus on process parameters such as flow, level, temperature, and pressure, and then branch out to include other concerns such as human factors and operating outside normal parameters. 26. Inspection. The external, internal, or on-stream assessment, or any combination of the three, of the condition of an asset conducted by the authorized inspector or his/her designee in accordance with the appropriate code. Note 1. Includes activities performed to verify that materials, fabrication, erection, examinations, testing, repairs, and any other data relevant to the equipment conform to applicable codes, engineering, and the owner-operator's written procedure requirements. Note 2. Inspection also includes the planning, implementation, and evaluation of the results of inspection activities. 27. Inspection plan. Strategy defining how and when an asset or component will be inspected, repaired, and/or maintained. Note: for the purposes of this document, the inspection plan is the product of an RBI analysis that details the scope, extent, locations, methods, and timing of specific inspection monitoring activities for determining the condition of a specific piece of equipment. It is the essential part of a risk-based management plan. 28. Integrity Operating Windows, IOWs, established limits for process variables and parameters that can affect the integrity of the equipment if the process operation deviates from the established limits for a predetermined amount of time. 29. ISO risk, a line of constant risk and method of graphically showing probability of failure (POF) and consequence of failure (COF) values in a two-dimensional plot where risk increases toward the upper right-hand corner. Slide number 663. Risk increases toward the upper right-hand corner. Risk is low, medium, high, extreme. 30. Logic model, a tool used to depict the effectiveness in depicting a combination of events that could result in a loss of containment event. 31. Management of change, MOC, a documented management system for review and approval of changes, both physical and process, to equipment prior to implementation of the change. Note: alteration of inspection plans may occur as a result of the change. 32. Management system. The framework of work processes and procedures is used to provide assurance that an organization can fulfill all tasks required to achieve its objectives. 33. Mechanical integrity, MI. The management system's work practices, methods, and procedures established to protect and preserve the integrity of operating equipment, that is, avoid loss of containment due to the effect of equipment damage mechanisms. Note: MI is one part of a process safety program. 34. Mitigation. Limitation of any negative consequence or reduction in probability of a particular event. 35. Physical model. A tool used to depict the progression of events and the release of a hazardous material to the environment. 36. Probabilistic. Systematic and comprehensive methodology to evaluate risks associated with a complex engineered entity which is based on or adapted to a theory of probability, subject to or involving chance variation. 37. Probability or likelihood. Extent to which an event is likely to occur within the time frame under consideration, that is, events per year. Note 1. The mathematical definition of a probability is a real number in the scale 0 to 1 attached to a random event. For a high degree of belief, the probability is near 1. Note 2. Frequency rather than probability may be used in describing risk. Note 3. Degrees of likelihood of probability can be chosen as classes or ranks like rare, unlikely, moderate, likely, almost certain, or incredible, improbable, remote, occasional, probable, frequent. 38. Probability of failure or POF. Likelihood of an equipment or component failure due to a single damage mechanism or multiple damage mechanisms occurring under specific operating conditions. 39. Process monitoring. Observing and tracking operating variables such that they are maintained within defined operating limits to minimize damage. 40. Process unit. A group of systems arranged in a specific fashion to produce a product or service. Examples: power generation, asset production, fuel oil production, and ethylene production. Challenge number 41. Thank you for your time and attention. If you'd like to challenge yourself, please answer these questions in the comments below. 1. Define asset integrity. 2. Why is not RBI a substitute for a process hazards analysis (PHA)? 3. What is ISO risk line?